Hello and welcome. My name is JP Metcalf, and today we'll go over one of the very first tutorials on the L3 Harris Geospatial website, and that is classification. Let's get started. All right, so I'm going to get into my browser and I'm going to type in L3 Harris Geospatial, and I'm going to go to the main page. And then I'm going to click on support. And under that pull down, there's self-help tools and then tutorials. And then since this is one of the first ones, I'm going to go to the 7th page, or the last page. And at the very bottom, this is done in December 16th, 2013. And I know that this is going to be a PDF that comes up. If I hover over it, it's going to say at the very bottom. So I'm going to right click and say open a new tab. And it looks like my little extension for PDFs comes up. I will make this a little bit larger so we can see the instructions. And let's check it out. We're going to do this as if I've never seen it. And in fact, I've never seen it. In this tutorial, we will use the classification workflow to categorize pixels in an image into many classes. In this first part of the tutorial, we'll perform an unsupervised classification. That type of classification clusters pixels in a data set based on statistics only and does not use defined training classes. Defining training classes would be supervised. In the second part of this tutorial, we're going to create training data interactively in the data set and use it to perform a supervised classification. Okay, so we're going to do unsupervised first and then supervised. Supervised clusters pixels in a data set and the classes based on training data that you define. Then you can select classes that you want mapped in the output. So we're going to be, in supervised, we're going to be guiding what we want to cluster pixels as. And here's some references. There's Mahalanobis, maximum likelihood, minimum distance. That's going to be remote sensing digital image analysis from J.A. Richards. I've seen that a lot. Spectral Angle Mapper with F.A. Cruzy. That'd be Fred Cruzy. He was my thesis advisor when I was at Naval Postgraduate School, so it's good to see that there. ISODATA, which is a unsupervised classification technique by Tao, Pattern Recognition Principles. And of course, you can always look up these references if you want to know more information about how unsupervised and supervised classification is performed in the algorithm sense. So now we're looking at the files used in this tutorial. They are available from our website, or there's this ENVI resource DVD. I'm not sure if those DVDs are circulating so freely now, but I'm sure you could contact support at l3harrisgeospatial.com if you really needed to have a DVD and request that. Otherwise, we are looking for the classification directory. So online, I'm going to come back to my tutorials page and look at the right-hand side, and it's going to say ENVI tutorials here. And then I'm going to want to download the classification. And it looks like if I look at the very bottom, it says it's coming from S3, so that's good. It's going to come fast. I have this downloaded already. But if it takes you, a few seconds or minutes to download this data, go ahead and pause the video and come back. For now, we're going to move on. It looks like we're looking at one file, which is a TIFF over Phoenix, Arizona. Of Quickbird. Okay, Quickbird is a satellite optical type imager. So we're going to probably be seeing, between half a meter and a meter if it's the panchromatic. Moving on, there's performing unsupervised classification. So let's get into it. The ISODATA method for unsupervised classification starts by calculating class means evenly distributed in the data space, then iteratively clusters the remaining pixels using minimum distance techniques. Okay, so it sounds like we are partitioning the data space of the image itself, so it's very reliant on the statistics of the image itself and what comes with it. Each iteration recalculates means and reclassifies pixels with respect to the new means. This process continues until the percentage of pixels that change classes during an iteration is less than the change threshold or the maximum number of iterations is reached. So that sounds like we're basically partitioning the image based on this mean that we've calculated, and the number of classes that we've picked, those are going to have their own means. And we're going to iterate over this until those means have met this change threshold, that they've changed from the mean, or the maximum number of iterations is reached. And let's assume that we can input these values, whether it's the change threshold or the number of iterations. So first step is to start ENVI. I have it up on the left-hand side already. I'm on ENVI 563. So at the time of writing, this was done in 2013. We are several versions past what we had in 2013, but I'm sure the process is very similar nonetheless. From the toolbox, we're going to select classification and then classification workflow. So let's do that. On the right-hand side, there's classification. I'm going to expand classification, and then there's classification workflow. Okay. Now it says the file selection panel appears. That's not until I double click. So I'm going to double click and open that tool. And indeed, we do have the file selection input dialog. And what we want to do is hit browse. And then we're always going to have this data selection come up. And what that really does is you may not want every part of the TIFF that we're selecting. We may want a spatial subset, like a smaller version of it, or a spectral subset. Let's say it's 4-band multispectral, which can be often coming from a satellite multispectral imager, or more often you can get into something like Worldview and have 8 bands. And we might only want to classify 4 out of 8. This is where we do that. So to get this file in, I'm going to hit open file icon. And then I'm going to go into, well, I'm already there. I'm at L3 Harris, tutorials, classification. And now what I want to look for is phoenixarizona.tiff. That's 22 megabytes. I'm going to hit OK. And then I can see here that we have 4 out of 4 bands, and we're using the full extent. And this looks like what we're going to use. So I'm going to hit OK. And then if I hit next, we are going to get into the next part of the workflow. And it looks like it opened our image automatically. That's good. Now, real quick, I'm going to put this over to the corner here and see if I can't zoom in and out and look at this image. It's a little dark. So what I want to do here is, if I look at the top ribbon, I see that the default, this is called a histogram stretch. The default is optimized linear. I'm going to choose this to something, let's say linear 2%. What that does is it cuts off the bottom 2% in the histogram lowest values and the top highest values, and says basically these are kind of outliers, and we want to look at everything in the middle 96%. Okay, a little bit brighter. So we're looking at, we have a golf course right down the middle, some barren fields. We have residential areas on the right, and it looks like some industrial buildings towards the top. And then it looks like some maybe about to be developed land, and this could be crops here. And then we have just really untouched land here. Okay, so, you know, I imagine in something in an unsupervised classification that we might want to, you know, maybe focus on either man-made, let's say roads, buildings. We see a lot of bright rooftop buildings here, vegetation, soil, and be able to separate those classes out, because they're going to have a much different spectral signature. So the next section says we're going to select no training, and that's going to indicate that we're only going to look at unsupervised classification methods. So I'll hit next. And then we're going to enter 7 as the requested number of classes defined. It looks like by default there's 5. So we're going to increase that by 2. And we don't need to change any settings on the advanced tab. So we're going to click next to begin classification. I'm very curious. I want to see what the advanced tab says. So here's what I was talking about, that we would normally have control over how many iterations from the mean, and defining the actual change threshold in percent. And it looks like the default is 10 iterations and the change threshold percentage is 2. Okay. So for brevity in this tutorial, it says don't touch that. Just keep the default. I'm going to look around here. It says I'm automatically put in the ISODATA parameters. Okay. I don't see anywhere I can change that. But I do know that there are other unsupervised classification techniques such as k-means. But it doesn't look like in this workflow that we have that option. I know if we were to get out of the workflow, it would have its own task. We don't have a preview button yet. Okay. I'm going to click next. And it says we're running unsupervised classification. And we get a little bar down here that says our progress, and we're about halfway. In the instructions, it says when classification is complete, the classified image loads in the view and the cleanup panel appears. Okay. So it automatically puts a new output in the layer manager called Unsupervised Classification. And then we have a total of 8 classes where class 0 is unclassified. And I'm not seeing an unclassified class. I usually see unclassified when you start to get into supervised and your parameters aren't, or the pixels aren't meeting the parameters that you have for your training data set. That's where you might want to see unclassified. You don't want the whole image to be segmented. And it looks like, before we get into this cleanup, it looks like our vegetation, our bright vegetation might be yellow. Let me check this. And what I can do is with unsupervised classification highlighted, I can slide the transparency slider and I should see the image underneath. And here's another little thing I can do here. I have the image. So this is true color. Now I can either change the bands here in the layer manager, and that's going to be by right-clicking, change RGB bands. And what I might want to do, if I'm very interested in vegetation, I know that this 4th band is going to be near infrared. I'm going to plug that into the red. And then I'm just going to click up and have band 3, which is red, as green. And then band 2, which is green, as the blue. Okay, I know that sounds confusing, but false color composites, you kind of get used to having it sound confusing. So I'm going to turn the transparency back down here. So it looks like yellow is bright vegetation. And then we have a mix. Let's look down here towards the bottom. I'm looking at this, it looks kind of hilly, not much, there's no man-made indications down here. And I'm going to see that those are classes 2, class 1, and class 3. Okay. See, these don't have names yet. Class 5 looks to be these barren fields. Also a mixture of class 6. So class 5, class 6. And then class 7. Let me see if I can get a better view here. Class 7 is going to be that industrial roofing, so bright. Okay. So where we're at here is it wants us to, first of all, let's go back and view our class image. Let's see, we got red. That's pretty much our roads. It thinks by default that it's going to be speckly and we might want to do some classification smoothing or aggregation to be able to clump some of these pixels together and make it have a nicer looking result. Now, we could pause and say, all right, this is what these classes are associated with, and then we can set those aside for, further investigation. But coming back, the following is a sample of the unsupervised classification results from part of the image. Your results may be different. Interesting. Notice that the amount of speckling that occurs within the residential areas. Okay. Wonder if I can find that area. It looks like, let's see, there's a road. Okay. So I'm going to zoom in. I found it. All right. Get my little workflow out of the way. I'm going to say my classification result looks identical. Okay. Good question. If you run unsupervised classification on the same image, same values, everything, same number of iterations, same number of change, do you expect to have a different result depending on what computer you're on or what run it was? Good question. We might be able to answer that later on. So it says cleanup is an optional step, but we're going to use it in this exercise to determine if the classification output improves. The cleanup options are smoothing, which removes speckling, and aggregation, which removes small regions, kind of like clumping. In the cleanup panel, keep the default settings, which we have, they're turned on, and we have the kernel size for smoothing is 3, so a 3x3 kernel. Aggregation has a minimum size of 9, that's default. And see how we have this preview checkbox that's up now. So if I hit preview, what it's going to do is it's going to run these parameters on a small subset. So I can, that turns out what we're going to do here. We're going to enable the preview option. I'm going to hit that right now. So what that's going to do is it has a little box and it's going to show me or preview what the result is going to look like with these parameters. And I can move this around and I can begin to decide if this is what I'm hoping to have in the end. And right now, let's say if I was really interested in this red class, which is class 1, if I really wanted that to be roads, I can see towards the bottom here that this other class 5, is starting to bleed over into this road. And I might be able to turn off my classified image and look underneath and see what I'm really dealing with in the actual image. And I can see that the road here, this nice dark road, is really wide compared to the road that I'm starting to lose here. And even in these residential areas, I'm starting to, it's probably like a few pixels wide. I might want to try different options for the smoothing and aggregation. So yeah, we did talk about a preview window that opened showing what the classification cleanup will look like with current settings. And if we click on the preview window using the selection tool, which is my cursor, the arrow icon located on the main, that's it, and drag it around the image to see how areas will be affected by cleanup step. We covered that. The image below shows this classification will benefit from using the cleanup step. You can see that much of the speckling noise has been replaced with smoother regions. Okay. And then, judging from what we see in the tutorial, we have this little bar up here, and that doesn't show up until I hover over the top of the preview window. And I can either pin this, I can hit play, or it looks like a forward and reverse. And what that's going to do is going to cycle through my layers. So this is acting like what we have in the toolbar. It's called a flicker. And I can move this around and I can flicker back and forth. So I don't have to keep moving the window out of the side of the way. I can even hit pause. And we can zoom out a little bit. And the preview window stays the same size. All right. We can check out different areas where we're just zoomed in. And if I turn off that layer, the preview window remains, and then I can drag it across my original image. And of course, I can enter values in here for different kernel size, minimum size, and then what's going to happen? Let's try this. Let's say I want to do a kernel smoothing of 5 by 5. So nothing happened yet, but if I hit enter, it's going to recalculate the preview. And then this is what it would look like with a 5 by 5 kernel. And if I wanted to aggregate a lot of these pixels, I thought that this was, still too speckly, if that's a word. Let's see, aggregate minimum size. Let's bring this up to 15. And then we start to have bigger clumps, basically. Okay. So I'm going to go back to what we have for the default values. And, you have to wait for the preview. I'm going to turn that off. I'm going to say that everything is fine. We're going to use the default output image type of ENVI. So what we're going to do now is hit next. We've decided that those parameters are suited for our needs. And then we get a new layer called cleanup. And if I turn off that new cleanup layer, I can see the difference. And one thing that really caught my eye is we have this grid-like pattern. And if I turn off this unsupervised classification, I'm going to see that might be like an orchard. If I had other GIS layers, I might be able to bring those in and tell exactly what this is. I think I'm looking at, let's see, there's no projection, which is kind of unusual for a Quickbird image. Or, yeah, no, that's right. So we're about 2,000 by 1,500 pixels. No projection. So I couldn't really bring up a map to figure out, what is this? But at the same time, this image is probably old, so things have changed by then. At any rate, this looks like rows of trees. And then we have, of course, several different classifications inside of here. But our cleanup basically says this is all class 2. Okay. Let's assume that's fine. And then we have export files tab. So if we have it checked, it's going to export the classification image, even though we have it in like preview mode or in memory in the layer manager. What we want to do is maybe we want to output these now. What are our options for formats? We have ENVI, no options. The classification vectors, I know can be time consuming in terms of processing. Let's see. We can export those. Our options are shapefile. And pretty convenient that it automatically just adds an underscore class and an underscore vectors and gives it the right file extension. So that's convenient. Let's look at the additional exports. We have export class statistics. You remember that our unsupervised algorithm operates off statistics. So we haven't seen any of those yet. We have seen the visual result of that. So maybe we do want to export these and we could maybe use them in other inputs. or evaluate these, I'm going to hit export these as well. All right, so we're exporting everything. Everything's automatically named. I'm going to hit finish. So we're exporting the results. And it's going to put it in the same folder structure that we opened the image from, which is convenient. You obviously have the ability to go in and change those file paths. So now, instead of, remember we had those generic names, unsupervised classification layer, and then we had cleanup result. Now these show up with the actual names, and I can see a lot of red here, and I know exactly what that is. That red is that shapefile, and that just vectorized our classification result. So real quick, before we move on to performing supervised classification, let's check out our exports here. I have the class. Let me turn off the shapefile. Now this is the cleaned up classification. Okay. And then of course I can always use that transparency slider as long as I'm selected. As long as I selected the class that I want to add transparency to, I'll view the image below. Okay, I might be able to stare at this and try and figure out the classes. But if I come up to vectors, let me turn the class image off. Okay, it shows me the delineation, but now I'm wondering, shapefiles can hold a lot of information. Do they have the class number associated with each? So if I right click the layer for the shapefile, can I go into view edit attributes? Little window should pop up. And I do have the class names as well as their area. And it says that we have 24,000 records. And at 24,000, I might consider, maybe I don't want to do too many querying, depending on my system. When you start to do that, it's very process intensive. But now that I know that we have class names, what if I wanted to filter records by attributes or just look at the properties? Let's go to the properties real quick. And it says my class names is the first attribute, and we're just showing a solid color for all of them, and that might not be useful. What about a rainbow color table where class 1 is black? Black's kind of hard to see, right? Pastels? Pastels might work, except I think a lot of these start to look, there's a lot of red looking. Let's try different ones. Volcano? No. Rainbow plus white? Sure. Let's see that. Okay. So this is similar to how our class image looks like, but then we can start to get rid of classes with shapefiles. I think that's pretty cool. We can use shapefiles as an input for training for a supervised classification. If we said that this was a good way of delineating the roads in our classification, then we might be able to pull this vector file and convert it to an ROI and say, these are roads. Let's find the rest. Okay. Can I fill it? Let's see, line color, thick, fill interior. It says false. What if I said true and hit apply? Ooh, this is starting to look real pretty. That's pretty cool looking. All right. And then of course I can always enforce other colors. So interesting to know, I can add all these different like palettes to a shapefile for visualization purposes. It's not built into the attributes. The only thing we have in the attributes right now are the class value or the class name and the area. Which brings me to another kind of thought on the attribute for area is, from what I can see, a lot of these larger fields are going to show up if I were to sort by the highest area. Okay. Before I leave this, I can try different. I don't even know what some of these are. And hit apply. All right, that's kind of cool. Or I could even make my own color table. All right. Let's see. I could save this symbology to automatically load with this shapefile. That's an option. But in the interest of time, because I can play around with this a lot, I'm going to hit OK. And then what we want to do is, before we move on to performing supervised classification, I'm going to remove the vectors. Remember, we still have these saved. I have the class. Actually, I'm going to open up my data manager, and I'm just going to make sure it's out of memory. And if I close the class image from the data manager, it's going to be removed from the layer manager. There we go. So I left this open because the instruction says leave the data manager and the file Phoenix, Arizona TIFF to open. Okay, so we have that. We go right back to that linear 2%. You know what? Maybe I'm going to try something else. Equalization? No, I didn't. Linear? We were at optimized linear before, and it looks like it's okay. That is a lot different. All right. Supervised classification methods include maximum likelihood, minimum distance, Mahalanobis distance, and spectral angle mapper. I know another one, and it's very fun to say, is parallelepiped. In this tutorial, we're going to use Spectral Angle Mapper, or SAM. The SAM method is a spectral classification technique that uses an ND angle, or n-dimensional, to match pixels to training data. It determines the spectral similarity between two spectra by calculating the angle between the spectra and treating them as vectors in a space with dimensionality equal to the total number of bands. Smaller angles represent closer matches to the reference spectrum. The pixels are assigned to the class with the smallest angle. When used with calibrated reflectance data, the SAM method is relatively insensitive to illumination and albedo effects. Okay, that was a lot of information. Basically, Spectral Angle Mapper will view our 4 bands. We have 4 bands of spectral data in 4-dimensional space. And similar to a 2D scatter plot or a 3D scatter plot, we are basically looking at a 4D scatter plot, and it's calculating the angle between your reference pixel and the pixel that you're evaluating. And if it finds out through the origin that it is within this cone, it looks like a cone in 3D basically. If it falls within that cone, then it's the same class. And when I say cone, this cone extends from the origin 0, 0 all the way out to the, if this is 12-bit data, it's going to be 4096 is going to be the upper limit. So if within that cone in radians, it's going to be considered part of that class. And the reason that it says that it's insensitive to illumination, and it says calibrated reflectance data, I've used this in the past for radiance data. Let's say, to drop the name again, Fred Cruzy, my thesis advisor, I had the pleasure of working with nocturnal lighting. So sodium vapor, mercury, LEDs for hyperspectral data, and I couldn't get that data into reflectance. There would be no use in it. So what I had to do is rely on the radiance, and you can have bright pixels and you can have very dim pixels, but ideally, in your head, that it could be the same light. So if it finds that pixel is within that angle, then we're looking at the same light. Hopefully, that's what the goal is, right? In the data manager, let's get back into it. The data manager, we're going to click the phoenixarizona.tiff file. All right, we have that. You have the file open at ENVI. You can drag the file name from the layer manager to the classification workflow in the toolbox. Really? From the layer manager into the class of, that's news to me. That's good information. I didn't know you could do that. I have a eager cat that would like my attention. Or we could have double clicked the classification tool to start. I don't know. I find the other one kind of useful. So if we click next, the file selection panel, okay. And I'm pretty sure what we're going to have to do is say use training data to get us into the list of supervised classification techniques. So we're going to say use training data. It says it's going to guide us through the supervised, workflow. That makes sense. So our workflow dialog has changed to define training data. And then we have a list of ROIs, which is empty. By default, the first one is red. The next one's going to be green, then blue after that. And we can add new ROIs. We can get rid of this one. We can get rid of all the classes. Okay. Now, in the algorithm tab, we're going to select Spectral Angle Mapper. So there's a little tab, and there's properties for ROIs. And if we go to algorithm, we're going to tell it which method we want to use. So we have 4 methods: maximum likelihood, minimum distance, Mahalanobis distance, spectral angle mapper, which is last on the list. And I know that the maximum spectral angle is going to be in radians, which is a number value. And if we say none, it's going to classify the entire image. So according to our tutorial, we're going to have it set to none. I think it's useful to use none just to see where things lie. And then if you find out that that's overclassifying, you can start to tune the angle in radians. So it says single value. That's using the same angle in radians across all classes. If we have multiple classes, which we don't have yet, we can use different angles in radians for different classes. Then we have another little checkbox at the bottom. It's called compute rule images. And a rule image is basically going to say for each class, it's going to be a black and white image that says what the angle in radians is for each pixel. So you can go back and use these to refine your classification. Okay. You can define training data from an existing ROI file, but for this exercise, we're going to interactively create our own. Okay, so if we're going to do our own, this is where your results might be different than mine. We're going to define 2 classes with at least 1 region per class or area. This is the minimum number of classes required to perform a supervised classification. 2. In the supervised classification panel, we're going to click the Properties tab. So we're going back. Change the class name from Class 1 to Undeveloped. Okay. So in the class properties here, I'm going to highlight this whole thing and get rid of it and say Undeveloped. And I wrote this in, and I know from experience that this is not going to rename our ROI until I hit Enter. There we go. So now in our layer manager, it says undeveloped. In our training data, it says undeveloped, and it lets us know that it's empty, that we don't have any areas in here. Okay. We're going to leave the class colors red. We're going to locate different areas in the image that are undeveloped. They should not contain buildings or grass. They should not be roads. Draw polygons inside of 3 of these areas. 3 areas, okay. Draw a polygon. Click in an undeveloped area and hold down the mouse button while drawing, left mouse, or click the mouse at various points to mark vertices. When you return to the starting point of the polygon, double-click to accept it. The ROI is then added to the undeveloped layer in the layer manager under the regions of interest tree. The following is an example of one polygon. Let's look at this real quick before I start. Okay. You know, I might be able to, I found the exact one here. So I have a little crosshair and it's real small to see. If I click once, I have a little red, let's see, like a red starting line. So I'm going to come down to the one other corner. And then I'm going to try to I'm going to go around this. There's like a little building in this area. And I can either double click but if I right click, I can say just complete and accept polygon, and it'll connect between the last place I clicked and the first place. Okay. And I think this is kind of cool. It actually adds a transparency. This is part of the workflow. So if I look up here, I can see beyond my ROI and into the image. And it added a 50% transparency, just part of the workflow. I think that's pretty cool. I didn't have to do that manually. Okay. And now what I want to do is I'm going to define a few more areas. So what I'm doing here, middle click turns into my pan. So I'm going to define another area here. And I'm going to avoid that gray area. That might be something that I don't want to capture. Undeveloped. So I'm going to grab different colors of areas, but I know that they're part of the same class. And the reason I want to grab different colors of areas spectrally, remember this is all about statistics, right? I want to make sure that our statistics have enough information to be able to grab these other areas. Okay. All right. Now we're going to add a class. And we do that by hitting this green plus icon. And now it says class 2, but we're going to rename this to vegetation. Remember I said that it's automatically going to be green. So it's going to be red, green, blue. And then I assume after that it cycles between the complements, which is magenta, yellow, cyan. Let's see, it is green, but it's not totally green, right? 0,128,0 would be like sort of green. I would expect 0,255,0. Okay. We're going to leave the class colors green. I'm going to locate different areas in the image that display healthy vegetation, such as golf courses. Okay, it doesn't say this in the tutorial, but remember that trick in the unsupervised is if I want to know what quote unquote healthy vegetation is, I'm going to go back to my Phoenix, Arizona layer. I'm going to change the RGB bands to band 4 is red. That's the near infrared. Band 3 is green. Band 2 is blue. And hit OK. And this is where that red is, it's kind of messing with us visually, but the green's going to be a lot different. So I'm going to go over to where this vegetation is. And maybe I want like a pretty large area. I know I'm grabbing like these sand traps, which wasn't necessarily vegetation. Okay. And let me grab a few more areas. And I might be restricting myself to just, the real healthy, frequently watered grass. This is Arizona. Maybe I'm not grabbing any trees. That's okay. I'm gonna grab this. Even make some of the other vegetation a different class, lower and near infrared. The next thing we're gonna do. Let's see how many do I have now. Let's grab one more for good measure. Make sure there's a tree in here. Okay. Now the next thing I want to do, the blue class, I'm going to change that to buildings. We're going to leave that as blue. We're going to locate different areas in the image that have rooftops. And we're going to draw polygons inside of 3 of these areas. Okay. Preferably rooftops with different brightness levels. And then if we look at an example, I'm going to move over to where I think that is. I found the exact area. All right. So I'm going to grab this. I'm going to keep inside here. And then we have this kind of gray. We'll grab a few more here. So this one looks like it has a little bit of a maybe HVAC type equipment on the top. I want to grab that too. And here. Okay. The next thing we're going to do is preview the classification result based on the trading data that we have now. So right now I can hit enable preview. And for this small area, wow, okay. So it says that my buildings class, let's move this out of the way. First, I'm going to hit the select. And I'm going to move this over here. It looks like our buildings is picking up a lot more than building. It's picking up pretty much man-made. So this road, okay. And then red is undeveloped. That looks fine. And then what should happen if I zoom out, the preview window stays the same size, but I'm actually seeing more of an area. So when I zoom out, I can see green is vegetation, or at least healthy. Undeveloped is actually vegetation in this area. Okay. And then that looks like water, but it's showing up as buildings. Okay. So I know that we only have so many classes. So not everything's going to segment into these 3 classes. But for the most part, that's what our land cover looks like, right? In the tutorial, it says the preview window shows that the roads are being classified as buildings. So you'll need to add a 4th class for roads. Perfect. So let's do that. I turned off preview. I'm going to add class. And that is yellow. So I'm going to rename this to roads. We're going to leave it as yellow. We're going to draw polygons within 3 different road types, including a freeway. You may need to use the zoom. Oh, I will need to use the zoom. Draw a polygon inside of the road. And then enable preview again. Okay. All right. So let me move around. And I'm going to grab this road here. Nice and dark. Oh, there we go. This one here. And I'm going to give it a lot of pixels. For your information, if you messed up on an ROI, all you have to do is just delete it and start over. And as you can see, this isn't all that hard. Actually, if you can see this, it makes it a little harder to define ROIs when you have what is called an interpolation on. And by default, it looks like some kind of interpolation. But if I go to nearest neighbor, now I'm going to be able to view the actual pixels when I zoom in. Can you see this? This looks like a yellow car, but you remember we're in a false color composite, and so it's not yellow really. So we got 2 pixels for a car or something on the side of the road. It's probably a car. So if that's a car and we don't have a projection, I'm going to say our spatial resolution for multispectral, which is multispectral is always lower spatial resolution than panchromatic. It's probably about 2 meters. If you think about the width of a car, I think that's a pretty good guess. Now this is really dark. It's so dark, I almost think it's water. So we actually might have confusion with water. Let me grab another road that isn't quite as dark, but it can't be confused with buildings either. Now we're going to hit preview. Is this going to be yellow? No, it's blue still. But what if okay. Blue's building. We don't want that, right? Yellow. All right. So here's what I need to do. I'm going to turn preview off. I have roads still. Okay. Zoom in a little bit. Now, can I still draw? It looks like we need a lot more training, right? So to get it back on the ROI cursor, I just clicked on my class. And I'm going to add a few more areas. Because the rows are so thin, we're not actually getting a whole bunch of pixels. So let me be a little bit more encompassing. Grab this little cul-de-sac looking thing. Now what does preview say? All right, look a little bit better. If I do say so myself, there we go. So I got a little bit of mix with the blue, but in this residential area, I'm seeing the main thoroughfare is yellow. Let me zoom out a little bit. See what this looks like on the larger scale. All right. I'm seeing linear features with our yellow road. So it's doing a little bit better. Now, this is just what we have set for none, right? And we can always go back and change the angle in radians. Ooh, so we're doing all kinds of stuff here. We're going to delete the roads region and then rename building region to developed, and then add 3 road training regions. Okay, so instead of having roads and buildings, we want to add these together and make this new overarching class called developed. Okay, so I'm going to delete that class. And then for my buildings class, we're going to rename. Let's let it delete roads. Maybe if I turn off preview first. Delete that class. There we go. We're going to rename buildings to developed. And then what we want to do is we need to go back and add the roads. Okay. It would have been cool if there was just like a button that said, all right, take this class, merge it to that class, and then let's change the name. We don't have to. Ooh, there's an overpass here. I missed that before. And I'm guessing this is the highway. Take a little bit of version of it. Like something in between, like the median maybe has vegetation, and I don't want to grab everything. Cars. And if I found this to be hard to view, blue is very dark. I might turn that transparency back down. So there's a brighter type road right there. I'll grab a little bit more of that dark road. It's really dark. Almost kind of looks like a riverway. Actually, now that I say that, that is probably water. Because there's an overpass here. And no cars. Yeah, that's water. Okay. Interesting. Can I go back? I messed up. Hold on. I'm going to delete this develop class. It happens. I'm going to add it. There we go. I'm going to go back to blue. No, blue. Blue. That's close enough. All right. So since we deleted that, what we need to do is grab some of these buildings again. Right. Building. All right. Grab a few more. Here's that one that has what I think are HVAC type equipment. You know, air conditioning because it's so hot. Arizona. A few more buildings. Doesn't really take long to add a bunch of ROIs. That's why I felt comfortable just saying, all right, delete this. We'll start over. I don't want water. All right. Here's that lighter type road. I just at least want to have that in my data cluster. And then, all right, this is for sure road. Or at least I'm pretty confident. I've never been to this part of Phoenix. I've been to Phoenix. I'll just grab the meat. It's fine. If it's not fine, I can always go back. Okay. All right, developed. Preview window should now show that roads and buildings are part of the new develop class. All right, so if I hit preview, I'm going to expect this to be blue. Ooh. It's I went because it's a little over classifying. The building, road, it's this kind of speckle stuff that's where I'm kind of like, that's not developed. That's like vegetation that's not doing so hot. So, okay. This is what I want to do is with my vegetation class, if I just click on it, I am going to find more vegetation. You remember this area? We know it's vegetation. I just want to grab a lot of this. And then, I could spend a lot of time and probably add more. How about this? It looks like grass. Oh yeah, this is a baseball field. to like varying degrees of health, right? You know, they may not water this every day, especially if there's some kind of water mandate that says you will only water so often. I mean, we all need to drink water. It's not really for the grass. If it rains, that's cool. Here we go. This is like a perfect. See, it's very healthy north, and then it kind of just drops off. Okay, so if I hit preview, I should see red is undeveloped, perfect. And then we have vegetation. And then if I move down, I'm grabbing, okay, this is looking good, I think. Okay. Turn preview off. Now, this is the comparing methods section. With preview option enabled, we're going to try each of the classification methods under algorithm tab. For detailed information on each method, we're going to see the references at the beginning of this tutorial. Here's a brief summary. Maximum likelihood. Let's get that preview back up. I'm going to zoom out. There we go. Preview on. And let's find an area that's diverse in terms of what we have for classes. Okay. So just looking at the classes, I can kind of see this. I see roads, I see undeveloped areas and vegetation. And this, if I move this out of the way, or, you know, I turn on transparency or some kind of flicker, this is even better. You know, I can see these blobs of what I know to be vegetation. Maximum likelihood. This is Spectral Angle Mapper that I have on right now. So let's change before I start talking. Maximum likelihood. As soon as I change that, it should rerun the preview. And we have a lot more pixels that are classified as vegetation. Okay. It assumes the statistics for each class and each band are normally distributed and calculates the probability that a given pixel belongs to a specific class. Each pixel is assigned to that class has the highest probability, that is the maximum likelihood of belonging to that class. Okay. And then we see what this kind of looks like in that area. And I'm pretty much in this area. Let me zoom out a little bit. I wonder if my ROIs, we move things around here. We're right about here. I think my ROIs might be better at the time of writing. Okay. And then if we switch to minimum distance, that uses the mean vectors for each class and calculates the Euclidean distance from each unknown pixel to the mean vector for each class. So Euclidean distance is not as the crow flies. The pixels are classified to the nearest class. Okay, minimum. What does minimum distance look like? It's got to reprocess. Wow, that is a lot different. Look at our developed class. That it looks a lot. Is that better? I mean, so I can see individual buildings here. That's good, right? We're missing the roads because that's what was developed. It thinks that vegetation, that the road is vegetation. But I'm liking how it very focuses on the buildings. But that's a lot different than what we saw with maximum likelihood. And it's not quite the same as what we see in the tutorial screenshot. That's okay. Remember, we have a lot of different ROIs, and you might too. If we switch to Mahalanobis distance, it's a direction-sensitive distance classifier that uses statistics for each class. Starting here, theme, statistics for each class. It is similar to the maximum likelihood classification, but assumes all class covariances are equal. Where we go back up, maximum likelihood assumed Was there an assumption in here, or was that minimum distance? Oh, I thought there was an assumption that, yeah, assumes the statistics for each pixel or each class and each band are normally distributed. It assumes that they're, normally distributed histogram. We're down to Mahalanobis. That assumed all class covariances are equal, which is a statistical measure, therefore is a faster method. All pixels are classified to the closest training data. All right, let me switch to Mahalanobis. See what that looks like. Okay. Which one's better? Roads are developed. That looks fine. We have a little bit of speckle with vegetation, but it might be vegetation. Let me zoom in a little bit. All right. Undeveloped is undeveloped. Okay. Interesting. Now let me switch back to Spectral Angle Mapper. Was that better? Maybe. Wait. So this red is undeveloped, but if I zoom in a little bit, the area that I'm looking at is indeed developed, and that's right here. So if I move this out of the way, I'm seeing this red here, and it looks like yellow buildings. Yellow in false color. And what did it do in Mahalanobis? If these buildings are blue, some are blue. Interesting. You know what that means? We need more training. Okay. Tutorial has examples of what each one of these algorithms are doing. It appears that either maximum likelihood or spectral angle mapper will provide the best classification result for this image and our training. For this exercise, we're going to keep spectral angle mapper as the algorithm. Well, if I don't want it to reprocess, I'm going to turn off preview. And what I'm going to do is hit spectral angle mapper. Click next. So now it's actually running the classification for the whole image. Remember, we were just previewing parts of it, and that's going to show up in the layer manager. And my thought is that this is a temporary file. It's just showing us what it looks like. So I'm going to zoom all the way out. And then we have a lot of developed pixels down here in the south, which I know it's not that developed. Oh. Okay. But maybe that's fine. I do like how this region right here is bright building and dark asphalt. And it's showing up as all blue. It's kind of cool. You know, it's obviously not perfect, but it got us 90% of the way. We still have cleanup to do. Because when supervised classification is complete, the classified image loads in the image window and the cleanup panel appears. Saw that. Cleanup is, of course, an optional step, but we are going to use it in this exercise to determine if the classification output improves. The cleanup options are smoothing, which removes speckling, and aggregation, which removes small regions. We saw that up above, but maybe it stands to be reiterated. In the cleanup panel, we're going to disable the enable smoothing option. Disable. Okay. Select and keep the default setting for enable aggregation. Default is 9 for the minimum size, which is pixels. The preview window should be still open. Oh, should it? I turned it off so I can hurry up and run that supervised classification. So let me turn that on. Okay. Let me zoom out a little bit and move my window. Okay. Now, if I turn enable aggregation off and preview is on, I should see the original or nothing. Enable. Interesting. What if I turn on smoothing? Am I going to have both smoothing and aggregation? Okay. Yeah, that makes sense. The preview window. Okay. We're going to drag it around the image to see how it affected the cleanup step. Let me zoom out. And I want to move my image around underneath the preview window, which is not a very clever trick, but it allows me to move the image. All right, I like this. That is a vegetation, definitely. And I can see that part of this field is what is considered undeveloped, and then part of it is healthy vegetation. If I move this underneath it, that looks to be true. I mean, I guess vegetation is undeveloped. And what I was hoping right here is you see this little red undeveloped area, is I was hoping that would be a building. This part is developed. Okay. Well, this is minor details that I'm nitpicking right now. But if we move on with enable aggregation and the default, I'm going to hit next. Now it's running the cleanup process on what we have in memory. And then again, we get to the save results or export. And then we have, of course, the export classification image is toggled to yes by default. And again, we have the ENVI format, which is .dat and a header. And it automatically named it underscore class. We may want to change that because remember our unsupervised result has already been saved out as the same names. So maybe the tutorial has some information on what we should be doing here. We're going to enter a valid path and file name for the classification image. Okay. Well, since we already have the beginning part, instead of, so we have AZ underscore class, I'm going to put, we used Sam, right? So I'm going to write in Sam. I know that we didn't use an angle in radians. Maybe I'm not going to write that in there. Classification vectors. I can just write right in this file path. This is going to be Sam vectors. Add another underscore. And then under the additional export tab, enable the export classification statistics. All right. And I know I did export those from unsupervised, but you know what I'm going to do? I'm going to add Sam in here. And then if we click finish, I shouldn't have any complaints about file names. I'm sure we've all had that problem before. Okay, so it got rid of everything in my export, or I mean, at least my layer manager. Now it's reloading the actual, there we go. Now it looks a little weird and red. That's because our vectors are in. If I turn my vectors off, it's adding like a red tint to it. But if I keep the vectors on, turn the class off, now I can see the vectors for the image. And again, we can always interrogate the attribute table. Let's see. Now the tutorial says that we are done. But what I want to do is view the statistics by opening the file in a text editor. Okay. So let's go. I'm in my GoPro. Let's go to L3 Harris tutorials. Ooh, excuse me. Let me go back. I have on a higher level all of my outputs. So I have Phoenix, Arizona stats. And then I should have another one for SAM stats. And that's going to be a little bit different. So if I look at this little preview thing, I have stats for what, 4 different classes? That makes sense. For SAM. But I should have, what, 8 classes? 7 plus the unclassified for Phoenix, Arizona. Let me look at this first. So I have this in Notepad. Ooh, I was expecting like a whole bunch of different kind of stats in here. We have area. And then percent. So the area is going to be in pixels because we're not projected. So it's not going to show like meters squared. We didn't have any unclassified pixels. And then class 1 takes up 9% of our image. Where class 5 was around 25% of the image. And this should aggregate to 100%. Okay. Now I could take the time to figure that out. I'm going to hit the I believe button. And now I want to look at the SAM stats. We have undeveloped is 50% of this image. Vegetation, 15%. Developed, 34%. Now, okay. Just, like assuming that our classification is close to what we want. Let's use this scenario that a city planner asked the remote sensing scientist of a particular company to figure out what the percentage of vegetated areas to developed areas. Let's say it has to do with producing oxygen for a certain area, or you get into the idea of the urban heat island effect. So that's where you might want to start to report, this is how many parks, this is how many golf courses we have, or the opposite, we're using too much water. So tell me what the percentage of healthy golf course areas are for a given area, and then we will decide whether we need to pull back on water for these areas. Just to use some like realistic examples. If you have any other examples that would be interesting for other people to know, go ahead and put it in the comments, and I'd be glad to engage or interact with you on some of these other ideas. Well, with that, it looks like we are done, and we covered unsupervised and supervised classification using the classification workflow in ENVI. And with that, I thank you for your time, and I will see you very soon for another video, since we have a lot to cover. Bye.